Now, in newer versions of C++, we can create anonymous functions by writing Lambda expressions. And if you've worked mostly with something like C++ in the past, you might not have seen these. But when I've worked in C#, I've seen Lambda expressions a lot. You'll see anonymous functions all the time in JavaScript. So let's look at a way that it might be useful to have an anonymous function. So I have created a simple program. We have this pet structure. It has name, animal, description, owner name, and year born. I just created a quick initialization and display function. And then the program itself well, we haven't implemented it yet, but it'll let you filter by animal, description, or older than. And I accidentally copied that. What happened? Okay, I misclicked and it copy-pasted something. So at the moment, none of these filters work, but we'll use Lambda expressions to do these. We can display the entire pet list, and that's everything that is in the system. But let's say we want to filter by the animal type, dogs, cats, whatever. So the user enters which animal they want to filter with, and I'm going to write a Lambda expression to just filter through, iterate through everything, and set up a list of just the dogs or just the cats, whatever they typed in. So as the results first, I want a new vector of pets. So we have our full list of pets here. This is all pets. But when we filter it, we want a smaller list. And afterwards, we will display the results. Now, if I wanted to, I could just basically implement it like this. If pet.animal is animal, result list dot push back pet. Like that, and we can display animals, dogs. So that does work. We can also implement this as an anonymous function. So let's do the syntax. We'll have a capture clause. We will have a parameter list. We'll have the function body. I'll just put this on the same line for now. And if we want to call it at the same time, we use a parentheses at the end. What the heck did I just type? Well, this is just the format for reference. There are different ways we can capture things. So if we do just an empty square brackets, it won't take any data from the same scope as where it lives. If we put in a equal sign, it will copy our other variables available here at that scope, and I'll make it a pass by value, I believe. And if we do ampersand, that will give us a reference. So then we'd have references to everything, and we could change it from inside of the Lambda expression, anonymous function. And we could change it from within the anonymous function. So I'm going to do that capture as this example first. And since we're just going to take everything that's in scope anyway and work with that, we're not going to add a parameter list. Now I'm going to add a function body, and I want to make sure it's called afterwards, after I've immediately declared it. And I'm going to use that same logic here. Now in this scenario, it's kind of weird to have an anonymous function right in the middle when I could just implement the same thing directly. But I feel like when I've used Lambda expressions the most in C#, it was to iterate through a bunch of data, write some sort of conditions, have it do some functionality, and then just return me a list of that data. So we'll just look at some different examples and how they work from here. But here I can run this. I can still filter by animal, type in an animal, and it will give me all of those specific animals back. Let's try another way we can implement this. So down here with the description, let's take this with us. We'll still need a result list, and we still need to display it at the end. But in this case, let's not capture anything. Now, if I don't capture anything, that means any data I use inside the function body has to be passed in here. So let's say we want to update result list. Well, I'm going to have a reference to that result list. If I need the description, because we're filtering on the description, I need to have that description. And if I need access to the entire pet list, I need access to it through the function parameters as well. Now, this gives us a little bit better control because we can make this a constant reference instead of just giving referential access to everything. And it kind of keeps things like pared down. It only has a certain amount of data it can work with. We can pretty much use the same functionality here. We'll throw this in here. We have pet.description. If these descriptions match, then we add it to the result list. Result list is passed in by reference, and so that should be okay. Now down here, this is where we're calling the function immediately after we've defined it. I need to make sure to pass in this result list here, pass in the description, and pass in the pet list. Now, just to make these clear, I usually don't use short variable names, but I'm going to rename this to RL. So this is our result list. Let's say D and pet list, so that you can tell these aren't exactly the same. This is information passed in and copied or references passed over. And then inside of here, we have these parameters that we use within here. So we can run this. Description, I think I did colors for the animals. Yeah, so like a white dog and a white, well, two white dogs. Or we could filter by tan, yeah, and get that cat, and so on. Okay, let's also look at another way we can do this. So filter by owner. Copy this again. And we want to filter by owner, and we'll have the same results and result list. So let's say we are going to return the data via the anonymous function. So in this case, I'm setting result list equal to the result from an anonymous function. In this case, this equal sign means, I believe, pass by value. So we're just going to copy anything that's in scope, have access to that by value. So I don't need to pass in any parameters again. And in the function body, since this is going to be assigned a value, we're going to have to return some sort of data. So inside of here, I'll do a vector pet, and this is our result list, but from within this scope. And we can still do the same parts here. And it will be added. It'll have access to pet list, which is no longer just passed in as an argument. Again, this is capturing everything that has access to in the scope. This is checking the owner. And we're adding to result list, and we need to return result list at the end. And we need to make sure to call this. So what this will do is now this variable, or this vector of pets, will be assigned a value, the value we get from this anonymous function. So we build and run, and it's owner name for that. Filter by owner. Let's do Rachel, and then there we go. All right, let's see another way we can do this. I am going to create an anonymous function earlier on in the program. Let's do it all the way back here. So what I'm going to do is I'm not going to call the function right away. We're just defining it. And I'm not going to assign it to a vector. We're going to say auto get old pets because one of the filters is filter older than. We can still do this capture, but we're going to need access to what is older than, so we'll do int older than age, and we can, let's see, probably want to pass in the vector as a reference as well. So just like when we were passing everything as parameters, let's pass this as a way we can return this data. So we'll put that here, and that's going to be the return data. Anytime that gets pushed, we'll push there. And then the logic, we have a current year here, they'll pass in an age, and we'll just estimate the age by saying if pet dot, if their, was it birth year? Let me look real quick. Year born. If the current year minus year born is greater than or equal to the older than age, then we'll add them to the result list. So I have created what looks like a variable, but I can technically call it now. I just have to pass in a number and a vector list of some kind. So now's not the best place to call that. We're going to call it a little later. Let me make sure this builds just in case. Okay. So down here in the older than, now I'm going to say get old pets. However, I need to declare my result list. We're going to copy this, put it down here, copy this, put it afterwards. We're going to need to pass in the age, I think, first. What do we do? Age first, and then the vector, age and result list. And now I can build and run. So filter older than, let's say older than 5. So then there are those pets. So even though it's a little weird to create a anonymous function in these contexts, it can be useful inside of a scope to do that, maybe at the top where you can kind of predefine some things, or if you were in the middle of processing data and you wanted to have that anonymous function to format things or filter things. I don't really have any good examples of where I've used it in like larger applications, since I mostly work on games and not so much like data processing, and I don't currently like do professional C++ development. I have in the past, but most of those code bases were C++ 1998. So I don't have any other really good examples for this, but I just wanted to kind of highlight the different ways this could be used.